So today we're going to talk about 0-4 counting techniques. If you look at your blank notes with me, we have a few vocab terms we need to talk about, a few formulas, and your calculator will help you a lot too, so make sure you have that ready. The first vocab word is outcome. So with this, it is the result of a single trial involving chance, a probability experiment. You guys have heard this before. What's the outcome that it might rain today, that kind of a thing. Sample space is the set of all possible outcomes. Usually we use a tree diagram. It's pretty easy with that. Independent event, if you think about it, if you're independent from your parents, you don't need their help, you're independent, right? If you're dependent, you depend on something. So independent is where one choice does not affect the others. They're independent of one another. Dependent is when one choice does affect the others. They depend on the other one. So we have a few options here. Fundamental counting principle. It looks kind of scary. It's actually really easy. If event M can occur M ways and is followed by event N that can occur N ways, then the event M followed by event N can occur M times N ways. That's really a scary way to say something that I'll show you how to do later. It's really easy. The fundamental counting principle is just where you take the number of options for the first thing right here, and you multiply by the number of options for the second thing and keep going down until you can't anymore. The next one is called permutation. Permutation and combination, you should have experienced in Algebra 1, but you probably don't remember it. Permutation is an arrangement of a group of distinct objects in a certain order. Order matters. That's super important. The difference between permutation and combination is that order matters, okay? So they rate it this way. P, permutation, of n comma r, so n objects taken r at a time. And here's the formula, NPR. This is a formula, but I'm going to show you in a second that your calculator has a button that'll just do it for you. So I don't even want you to look at the formula. We're just going to use our calculator. So don't worry about this at all, okay? Permutation, order matters, calculator. Combination is where order doesn't matter. So the object selected or the order of the object selected is not important. So again, we're going to plug this into our calculator. We don't have to worry about any of that. Your calculator does it for you. Okay? So an example of permutation versus combination. Permutation order matters. Usually they give you something like president, vice president, secretary. The order matters, right? You want to be president. That matters. Combination, something like a sandwich. It doesn't matter if you put the turkey and then the lettuce or the lettuce and then the turkey. So unless you're OCD, I guess. All right, so let's just get started here. Number 3. Dan is renting a tux for prom. There are 2 jacket styles, 3 types of pants, and 6 colors for the vest. How many different ways can he select his attire for prom? So this is going to be the fundamental counting principle. It's really easy. You just take the number of options you have times the next number times the next number. So let me see if I can remember how to do this. There we go. So how many types of jackets do we have? 2, right? Times how many types of pants? 3. Times how many types of colors for the vest? 6. The fundamental counting principle says you take the first option times the second option times however many more options you have. So it's 2 times 3 times 6. Our answer is 36 ways. It's really easy, okay? The next question, determine whether each situation involves permutation or combination. It's very important that you decide that first because that depends on what button you're going to push on your calculator. Then we're going to actually solve it, okay? Charlita wants to take 6 different classes next year. Assuming each class is offered each period, how many different schedules could she have? So again, we need to decide if it's permutation or combination. That's really hard to do sometimes because sometimes you think it could be like a matter of opinion or something. So just the first time you go through these things, just kind of like listen to whether I say it's permutation or combination, and then you'll always know after that. So with this, order actually does matter because you can't have period 1 in period 6 kind of a thing. Here, order matters because period 1 comes and then period 2 and then period 3, right? So order matters. So here, we're talking about permutation. Sometimes it's easy to tell whether it's permutation or combination, and sometimes it's tricky. Whenever I ask you on a test or a quiz, it'll be very clear which option to choose. Okay, so how many things are we choosing from? She has 6 classes to pick from, right? So we're taking 6 things. And how many classes is she going to take? 6. So it's 6, choose 6. That's how we read it. She has 6 classes and she's going to take 6. Now, if they said she has 6 classes to choose from and she's going to, I don't know, only do half days or something, you'd put a 3 here. So here's where you definitely want to get your calculator out. I'm going to try to find one that's like the one that you guys use. Most of you use that, the one that I have. So this option, the 6P6, where is that? You see the PRB button in the upper left-hand corner of your calculator? It says PRB. If you push that, you have an NPR and an NCR and an exclamation point, okay? You want the P one because we're doing permutation, okay? So you'll have to get rid of it here in a second, but that's the button that you want. Most of you have that calculator. Some of you have the one like mine, the one that I like. If you have that button, it's actually on your calculator, if I remember right. I think it's in yellow. Yeah, it's in yellow above the number 9. So you guys are going to want to push that. So hit the clear, okay? We want to do 6 and then the P and then the 6. So push your 6. Somehow get to the NPR button, right? Push enter. And then 6. And what do you end up getting? It's 720. So she could essentially come up with 720 different possible schedules. You could have also done the fundamental counting principle here. She wants to take 6 classes. And how many options does she have for the first one? 6. And then 1 less because she's taking that class. 5, 4, 3, 2, all the way down to 1. And that's 720 as well. They're both 720. Whichever way makes more sense to you is fine. Okay? Backside. How many ways are there to choose the winner and first, second, and third runner-up in a contest with 10 finalists? So again, there's more than one way to do these all the time. I'm going to try to force you to try the permutation combination option first, okay? Does order matter? Do you want to win? Of course you want to win. Or order matters, right? So it's permutation. How many options do we have? How many people are trying out for the winner? 10, right? 10, but how many are we choosing? Well, we're choosing the winner, that's 1, and then first and second and third. So how many options is that total? 4, right? So 10 people, but only 4 awards are available. Okay? So plug that in your calculator, do the 10 and then the P and then the 4. It matters. If you accidentally push that C, you're going to get a whole different answer, so don't do the wrong one. And you should get 5,040. Actually use your calculator, please. Don't just write down what I wrote down. Again, you could use the fundamental counting principle. There's the winner, there's first place, second place, third runner-up, right? 10 finalists are available here, and then 9, and then 8, and then 7, and it's still 5,040. Okay? So now let's go to the bottom. How many different 2-topping pizzas can be made if there are 6 options for toppings? So again, you have to think first, does order matter or not? Okay? Obviously, again, technically, order doesn't matter. It's a pizza. As long as it has all the toppings, you don't really care what order they put them in. So this is combination. How many things are we choosing from? How many options do we have? 6. How many are we choosing? 2. 6C2, right? So again, that's a button on your calculator. You don't have to know that formula. I don't care. You've got a calculator for that. So you push your 6, you get your C button, which is by the PRB if you have the normal calculator. If you have the other ones, you might kind of have to look, have somebody help you, right? And what did you guys get? 15. There's 15 possible combinations for that kind of a pizza. All right, one more. A security keypad has numbers 0 through 9. How many 5-digit codes are possible if the first digit cannot be 0 and no digit is repeated? For this kind of a question, I usually just fill in my blanks. I don't think about permutation or combination. It's just easier for me to write some blanks. So how many digits are we going to be punching in? 5, right? 1, 2, 3, 4, 5. Then they gave us some stipulations on them. They said there's 0 through 9 on the keypad. How many 5-digit codes are possible if the first digit cannot be 0? So how many options do we have in between 0 and 9? That's 10 options, right? But they said this one can't have 0 in it. So really now I'm down to 9 options for this first answer. There's 10 digits in between 0 and 9. Oh, can't have 0. So really I'm down to 9. Now, no digit can be repeated. So again, normally there's 10 options, but I can't repeat this one. So I'm back down to 9 because 0's back in my options. And then go down by 1, 8, 7, and 6. I'm going to say it one more time. I know that might be kind of confusing for some people. If they hadn't given me this restriction, I would have just said, oh, I could pick 10 numbers here, 9 numbers here, 8 numbers here, 7 numbers here, 6 numbers here, because I can't repeat any. So it has to go down by 1. If I could have repeated them, they would have all been 10s, right? The reason this one is 9 is because you can't have a 0 here. But you can here, and you can here, and you can here, and you can here. So that's why it went back up again. So actually punch that in your calculator. There's no shortcut. You've got to just do it. What do you get? 27,216. Awesome. If you're confused, ask the sub, deposit, lean to a neighbor, whatever you need to do, okay? Last question. Before 1995, area codes were of the format XYZ. So like 317 or 812 or whatever your area code was. How many area codes were available? So before 1995, how many area codes were available? So again, there were restrictions. X was the numbers 2 through 9. Y was the numbers 0 or 1 only. And Z was 0 through 9. So again, we're talking area code X, Y, Z. How many options do you have for X? How many numbers are in between 2 and 9? If you don't remember how to do that without actually counting on your fingers, you subtract the 2 and you add a 1 back in. So 9 minus 2 is 7, plus 1 more is 8. How many options are available for the Y? 0 or 1. So how many is that? Obviously 2, right? How many are available for the Z from 0 through 9? There's 10 there. So 8 for the first part, 2 for the second, and 10 for the third. Use your calculator, actually punch it in, and what do you get? 160. Very good. In 1995, the restriction of the middle digit was removed, allowing 0 through 9 instead this time. Now how many are available? So what they're saying is the first one and the third one, nothing changed. So that's still 8 and 10. But the middle digit is now allowed to be 0 through 9. So how many options are available for the middle digit? 10. So multiply, and what do you get? 800. Okay? That's it for the notes. If you're really struggling, ask a friend, ask a neighbor, go see the tutors in the library, whatever works for you, and then you'll be all right. The assignment's obviously at the bottom. Check your answers with a neighbor, whatever works for you.